For our last lesson in our section on trigonometry, the questions are to solve right triangles. We actually have done a lot of this earlier in the unit. I'm trying to move this out of the way. And the reason being because I went through and talked with you guys about using the second tangent, second sine, second cosine, so inverses, earlier in the lesson, earlier in the chapter. So for this problem right here, they're asking us to find basically all of the missing dimensions. So just a little bit of overview. A triangle obviously has 3 sides and 3 angles. In a right triangle, we know that one of those angles is 90 degrees. So depending upon the information that they give us, we need to end up having the length of all 3 sides and the measurement of all 3 angles. In this problem, if we know that this is 90 and this is 42, so 42 plus the measure of angle B have to add up to 90. Measure of angle B is 48 degrees. Now we want to find the measurement of the missing side. So I'm first going to look at the side CB. I can actually set this up 2 ways. I can write, let me put an X here just so we can keep track of what we're finding. If I deal with the 42-degree angle, X represents the opposite and 70 represents the adjacent leg. And that's the tangent ratio. So I can use that formula to find X. Since I know that this angle is 48 degrees, I could also use the tangent of 48 degrees. But now my ratio is flipped. 70 is the opposite, and X is the adjacent. So in my scientific calculator off screen, I am going to put in 42 tangent is 0.9004. I'm going to multiply that by 70, and I get 63.028. I'm going to round that, since it says round to the nearest tenth. That's 63.0. So for the tangent of 48, I'm going to do 48 tangent, which is 1.1106. And as I've spoken about in other videos and classes, you start to realize now that you can just do 70 divided by 1.1106, save myself a few steps, and I get 63.028, so once again, it's 63. So the measure of angle X is 63. Now I could use Pythagorean theorem to solve this, but because of rounding, what is going to be best is to use trig ratios. Trig ratios are going to always be the most exact. So now I'm going to call this y. To find y, if I use the 42-degree angle, and I'm going to use the information they originally gave me, I just make it most exact. 70 is the adjacent, y is the hypotenuse, that's cosine ratio, or I could have used 48, which is opposite over y, because I'm finding hypotenuse, and that's the sine ratio. So my off-screen calculator, 42 cosine is 0.7431. I'm going to end up taking 70 and divide by 0.7431, and I get 94.19999, which is going around to 94.2. Let's see what I get when I do sine. So the sine of 48 is 0.7431. 70 divided by 0.7431 is 94.19999. So 94.2. And that's what it means to solve a right triangle. So now we're going to go through and solve right triangles. This was your homework. And we'll do each of the problems. You had the evens. So first, looking at problem number 10, they give you a 40-degree angle. So that means the measure of angle K has to be 50. 40 and 50 is 90. 90 plus 90 is 180. So I'm just for right now going to call this angle, side length X. So if I want to find side length X, and I'm going to work with what they've given me. They originally gave me a 40-degree angle. I want to find the adjacent. They gave me the hypotenuse. Adjacent over hypotenuse is cosine. So in my screen calculator, 40 cosine is 0.76604 blah, blah, blah. Since this is going to be multiplied by 8, I'm just going to leave that in my calculator. And 6.128, round to the nearest tenth. So that's going to be 6.1. That's messy, so I'm going to clean that up here. Okay. Now for what I'm going to call side Y. And that is now adjacent sorry, that's not adjacent, that's opposite. And they give me the hypotenuse. I'm dealing with the 40-degree angle. So since y is opposite 40, and I'm dividing by the hypotenuse, I should have put 8 there. So since y is opposite the 40 and I'm dividing by the hypotenuse, that's sine. And the sine of 40 is 0.6427, etc. I'm going to leave that in my calculator. I'm going to multiply by 8 and I get 5.14. So roughly 5.1. If I want to check my work, I can check it with Pythagorean theorem, meaning 6.1 squared plus 5.1 squared should equal 8 squared. 6.1 squared is 37.21. 5.1 squared is 26.01. And that should equal 64. 37.21 plus 26.01 is 63.22. So I'm off a little bit. If I want to, I can recheck my rounding. Maybe there's a problem there. Otherwise, it may just be that had I rounded to the 100th, it would have been more exact. But just real quick, the 40-degree angle, opposite side it was y, sine, .14, that does round to 5.1. And I'm just curious if I check the 5.14 and 6.1, sorry, to check the 6.1, that is cosine of 40 equals the adjacent over the hypotenuse. 7.66. 6.128. I'm just curious. If I used the more exact measures, how would my answers look here when I check it? So if I did 6.13 quantity squared plus 5.14 quantity squared, would that get me closer to 64? Is 37 point, I'm going to be as exact as I can here. 5.14 so 26.4196 plus 37.576 equals 63.9956. So once again, if I am more exact with rounding than the problem asks me to be, I get a more exact answer. So that's also a good practice, a good explanation for some of you who say, well, when I use Pythagorean theorem to find it, how come it's not as exact as using ratios? Also, the more you round to, in the real world, the more exact your answers are going to be. Let's move on. I'm not going to keep checking every one because I think you got the gist of what to do. So here, if this is a 57-degree angle, this would be a 33-degree angle because they have to add up to 90. If I have the 57-degree angle, notice I write 57 degrees first. I'm going to write tangent, sine, or cosine once I set it up and decide what I'm doing. So 15, I'm first going to do opposite over adjacent. So that's tangent ratio. Okay, the tangent of a 57-degree angle is 1.5399. Now I can just divide 15 divided by 1.5399 and I get 9.74. That's going to round to 9.7. Now for y, which is the hypotenuse, I'm going to be dealing with a 57-degree angle. The opposite was given to me, a 15, and I want to find the hypotenuse. Opposite divided by hypotenuse is sine. So once again, when I set these up, I write the angle that I'm dealing with, you fill the numbers in the ratio, and then I decide whether I'm using sine, cosine, or tangent. That's 0.8387. Okay, 15 divided by 0.8387 is 17.9. For number 14. In this case, they've given us two dimensions. They want us to find the missing side length. So we can use Pythagorean theorem, which is what I'm going to do, and then we can also find D and F using ratios. If I want to find the measure of angle D, I want to find the measure of some unknown angle that I'm going to call D, and I have the adjacent, and this is the hypotenuse. So adjacent over hypotenuse. And that is cosine. This is where I'm going to end up using the second button. okay? Because I can't put into my calculator what's the cosine of D. So 3 divided by 9 is obviously 1/3, and as a decimal, that's 0.33333. So I'm going to put that in my calculator. I'm going to write here what I'm doing. Technically, I'm finding the inverse. You don't have to write that, but I'm going to. So I put that in my calculator, and now I hit the second and the cosine inverse button, and I get 70.5. Round decimals to the nearest tenth. I could use 180 degrees to find the measure of angle F, but if I use trig ratio, it's going to help me ensure I didn't make a mistake somewhere. So I'm going to do that. In this case now, I'm finding the measure of angle F, and I'm given the opposite over the hypotenuse. And that's, messy handwriting, and that's the sine. And we talked about this. Remember that if you have two angles that are the non-right angles in the triangle, the sine of one is going to be this cosine of the other. So 0.3333 second sine is 19.469. So 19, oops, not there, 19.5. Write that here. Is angle F. Okay, so now to find just the missing side, I am going to use Pythagorean theorem because I try to use most of what they give me. So 3 squared is 9 plus b squared is going to equal 81. 81 minus 9 is 72. Now they're asking for it rounded to the nearest decimal. So 72 square root to the nearest decimal is 8.48, which is 8.5. I may ask you, though, in simplest radical form. So what you want to do when you do that is you want to do factors of 72. I'm first going to use 9 times 8. The square root of 9 is 3. Okay? Now, 8 I can factor further into 4 and 2. The square root of 4 is 2. Since I already have a 3 here, 3 times 2 is 6. You also could have realized that 72 is made up of 36 times 2, and the square root of 36 is 6. So no matter how you factor it, you're going to get the right answer. So that's it for number 14 as a decimal and in simplest radical form. Now I'm going to move on to number 16, which involves some decimals. I'm first going to find the measure of that leg. That's the opposite of this angle. I'm giving the adjacent. And that's a 43.6 degree angle. Opposite over adjacent is tangent. So off screen on my scientific calculator, 43.6 tangent times 5.2 is 4.95. So that's going to round to the nearest decimal, nearest tenth to 5. And then to find the hypotenuse, which I'm going to call y, 43.6 degrees. I'm given the adjacent originally. I want to find the hypotenuse. Adjacent over hypotenuse is cosine. So 43.6 cosine is 0.7242. So So I'm going to end up doing 5.2 divided by 0.7242, and I get 7.18 for y, for the hypotenuse. To find angle A, I'm just going to do 90 minus 43.6, and I get 46.4. So those are your answers for 16. And then for 18, which involves fractions, I'm going to deal with a hypotenuse of 10 7/8. Since 7/8 I can make a terminating decimal, I can use that. So the hypotenuse is 10.875. I'm first going to find the side opposite the 29.9 degree angle. Opposite over hypotenuse is sine. So 29.9 sine is 0.4985. I'm going to leave all that in the calculator, times it by 10.875, and I get 5.42. So that means that side to the nearest decimal is 5.4. Now I'm going to do the same thing here. I'm going to just call this y so you know which one I'm talking about. But y over 10.875, I was given a 29.9 degree angle. Adjacent over hypotenuse is cosine. 29.9 cosine is 0.8668. I'm going to leave all of that in the calculator, times it by 10.875, and I get 9.427, which is going to round to 9.4. I hope now you feel a little bit more comfortable. There are other ways to solve each of these problems. I just tried to use the information that was given each time I was setting it up, rather than using the answers I had found to solve any potential rounding issues.